So, if you come across this problem on your QAMT Problem Solving Competition paper in 2026, what can you do? On the Great Court, there is a 12 meter by 12 meter patch of grass. In each of the corners, there's a water sprinkler covering a quarter circle with area 12 pi meters squared in the picture. What is the area of grass that does not get watered? Okay, so in this diagram, this is 12 meters, right? Okay, these are quarter circles. So let's just take one quarter circle. We don't know the radius yet. I'm going to let this be R. And the area is 12 pi. Remember, pi r squared is the area of a circle, and the quarter of that is 12 pi. Multiply both sides by 4, so this goes away, and I get 48, right? And I divide by pi, and I get r squared is 48. R is just the square root of 48, which is 4 square root of 3. Okay. What does that mean? Well, R is 4 square root of 3. Could I draw a perpendicular line right down the middle here? I notice that there is, what, a right angled triangle here. Okay. So R is this. So this is 4 square root of 3 here. And because this is 12 meters, this is going to be half of that, which is 6. Okay? So what do we see there? Two square root of 3 times the square root of 3. What is that going to be? Well, 6 squared is 36, and this squared is 48, right? So by Pythagoras' theorem, the square of this has to be 48 minus 36, which is 12. So what is the square root of 12? That's 2 square root of 3, isn't it? So this is a right angle, and this length is twice of that length. So we have a 30, 60, 90 triangle. Just imagine half of an equilateral triangle. Okay. So now we have that. What can we say? What is the area of this triangle? The area of that is half times base times height. And that's just half times 6 times 2 square root of 3, which is 6 square root of 3. That is the area of the triangle. Okay. Now, I'm going to draw in this sector here. Okay. This sector that looks like this is 30 degrees. And this is R, which is 4 square root of 3. What's the area of that? Well, since a whole revolution is 360 degrees and this is 30 degrees, this is 1 on 12 of the area of the full circle, which is pi r squared. Okay, pi by 4 root 3 squared on 12. We said 4 root 3 squared was 48, so that's 48 pi on 12, which is 4 pi, right? So this is just a third of the area of the quarter circle. Okay, now we can get to work, right? So the area of the grass that does not get watered, because these are water sprinklers sprinkling, this is the area that we want, right? So this is a bit of sloppy notation. The area of this. So can we say the big square? We take the big square and we subtract 4 times the quarter circles, right? We subtracted off all of these. What has happened? I've subtracted this part off from that quarter circle, and I've subtracted that part off from the bottom quarter circle. So I've subtracted off this one twice. So I need to add it back. And the same goes for this, and that. So I guess I have to add back 4 times that shape, which I'm talking about that shape there. Okay. So I do that. And now I can write this as the square minus 4 times that. But what is 4 times that? I can say 8 times that part. That's half of that. So 4 times that there is just 8 times one of those halves. And 8 times the halves is 8 times the sector minus our favorite triangle, which is these two here, right? Okay. The area of the big square, that's 12 by 12. So that's 144. Okay? 4 times the area of the quarter circle, which was given 12 pi. And now we have 8 times this, where this is the area of that, which is 4 pi minus 6 square root of 3. I'm just plugging in these values. 144 minus 48 pi. If I expand this, I get plus 32 pi. And then this is minus 8 times 6, 48 square root of 3, which is 144. I collect these like terms, 16 pi minus 48 square root of 3. And that is our final answer of the area that we wanted. And it's okay to leave it in this third form like that. That's fine. So that is our final answer. And we are done.